Hello and welcome. In this video, we will determine the average rate of change from a function defined by a formula, and then we will gain more practice deciding what the average rate of change does and does not tell us about the behavior of a function. So quick review: for a function g defined on an interval from a to b, the average rate of change of g on the interval a to b is the quantity g of b minus g of a over b minus a. And we've seen that the average rate of change represents the slope of this line between a g of a and b g of b. We also have seen that the average rate of change tells us how much the function rises or falls on average for each additional unit we move to the right on the graph, and that the units on the average rate of change on an interval from a to b are the units of output per 1 unit of input. So we saw the situation before with the table of values, and now we're going to look at the situation defined by a function. The number of students in GVSU's Mary Idema Pugh Library at various times between 12 noon and 11 p.m. on December 12, 2019 can be modeled by the function m equals p of h equals 3.1 h squared minus 130 h plus 1,375, where h is the number of hours after midnight. So we're going to compute the average rate of change on the interval 12 to 15, and then 15 to 18, and 18 to 21. So the average rate of change from 12 to 15 means that we'll need to find the change in output, p of 15 minus p of 12, divided by the change in input, 15 minus 12. And to find p of 15, we know the input is 15, so we'll replace h with 15. We'll have 3.1 times 15 squared minus 130 times 15 plus 1,375. And then we will subtract p of 12. Because we're going to have multiple terms, we need to remember parentheses so that we subtract everything that makes up the quantity p of 12. P of 12 is going to be 3.1, 12 squared, minus 130 times 12, plus 1,375. So there's our change in output, and we'll divide that by 3. And when we do that, we end up with negative 46.3. So I'm not going to calculate the next two average rates of change. You should actually take a minute and practice calculating those average rates of change on your own. All right, so hopefully you did go ahead and actually practice finding those average rates of change on your own. You should have gotten negative 27.7 for the average rate of change between 15 and 18, and for the average rate of change between 18 and 21, you can get negative 9.1. So part B says plot the line segments whose respective slopes are the average rates of change you computed in A. So recall that the average rate of change on an interval describes the slope of the line containing the two endpoints of that interval. So from 12 to 15, the average rate of change represents the slope of this line. So this line has a slope of negative 46.3. From 15 to 18, the average rate of change represents the slope of this green line, negative 27.7. And then from 18 to 21, the average rate of change is the slope of this orange line, negative 9.1. And remember, these average rates of change are telling us how much, in this case, the function falls for every 1 unit increase in the horizontal direction. All right, so now let's look at what the average rate of change tells us about trends in this function. So at the top here, we just have a reminder that m equals p of h, tells us the number of students in the library, and h is the number of hours after midnight. And we see the three average rates of change that we previously calculated. What do the previous calculations tell us about the number of students in the library between 12 noon and 9 p.m. and what don't they tell us? So I'm going to give you 4 examples of some valid conclusions. There could be many more valid conclusions to make, but this is just an example. So first we could say between 3 p.m. and 6 p.m. the function m equals p of h falls at an average rate of 27.7 students every 1 hour. So we know the function falls because the average rate of change was negative from 3 p.m. to 6 p.m. That was the average rate of change from 15 to 18. And we can say that it was falling at an average rate of 27.7 students every 1 hour because we know average rate of change describes the change in output divided by the change in 1 input, or per 1 unit of input, I should say. Second, we could say that on average, the number of students in the library is decreasing between 12 p.m. and 9 p.m. because all of the average rates of change are negative. So when we found the average rates of change from 12 to 15, and then 15 to 18, and then 18 to 21, h equals 21 represents 9 p.m. And all 3 of those average rates of change were negative. So we know on average, the number of students in the library is decreasing between 12 and 9 p.m. Thirdly, we could say that on average, the number of students in the library is decreasing fastest between 12 p.m. and 3 p.m. And we can conclude that by comparing the absolute value of the average rates of change that we calculated. So the absolute value of negative 46.3 is positive 46.3, and that's greater than the absolute value of the other average rates of change. That allows us to conclude that the number of students in the library was decreasing fastest between 12 p.m. and 3 p.m. on average. All right, the last valid conclusion is a little less obvious, but we could also say that the difference in the number of students in the library from 12 p.m. to 3 p.m. is 138.9 students. And here's how we can determine that. We know that the average rate of change is p of 15 minus p of 12 divided by 15 minus 12. And we know that that equals negative 46.3. So if we were to multiply by 3 to get that 3 out of the denominator, we would end up with p of 15 minus p of 12 equals negative 46.3 times 3, which is negative 138.9 students. And that quantity, p of 15 minus p of 12, that represents the difference in the number of students in the library from 12 to 3 p.m. All right, again, that's just an example of some valid conclusions that we can make based on our average rate of change calculations. Let's look at a couple invalid conclusions that students typically try to make. So some students will try to say that the average rate of change in the number of students is decreasing from 12 to 21, and that is false. If you look at these values, negative 46.3 to negative 27.7, that is an increase. So the average rate of change is actually increasing from 12 to 18. I think what the student probably meant to say there is that the function p of h is decreasing because the average rates of change are negative. So be careful about that. And then one more common invalid conclusion would be something just a little too general. The number of students in the library is always decreasing. We don't have any time interval there, So that statement ends up being false, because if you look at 21 hours and beyond on the graph, you actually see that the average rate of change would be positive. So the number of students in the library would be increasing. Or if you used our actual function, P of H, you could calculate the average rate of change from, say, 21 to 23 hours, and you would see that you get a positive average rate of change. So be careful to make sure that your sentence is specific and precise enough to make sure it is always true.